Good morning to everyone again. My name is Borgarino and I'm the tutor of Paolo Lucchi. Paolo Lucchi is now in Bordeaux, spending 1 year internship in collaboration with the IMS lab, developing the topic for this future research is the developing of 60 GHz PLL. During his first research year, Paolo was focused on the design of a quadrature VCO. Here on this slide, on your left, you can see the schematics of the designed oscillator, and on the right hand, you can see the microphotograph of the fabricated prototype. This was the first prototype. The prototype was tested. Here we have a first comparison between the experiment and the simulations. GTSSA and FFA are acronyms relating to the case, to the corner case of the technology. Here again, we have on the other hand comparisons no more in terms of DC characterization, but in terms of RF characterization. On the left, you can see the spectrum of the signal generated by the VCO. She is oscillating at around 12 GHz. On your right hand, you can see a comparison between the simulated and measured tuning range. You can see that there is a difference between measurements and simulations. Therefore, before the test of the first prototype, the research activity was focused on investigating why there was these differences. Again, here a comparison summarized in the tables between simulation and experiments. The first device that was believed responsible for the difference between simulation and experiments was the inductor. Here we can see the layout of the inductor that was simulated using electromagnetic tools. And the inductor was simulated under two different conditions. On the left, the differential, and on the right, the single-ended configuration. The comparison was carried out between the two different configuration of the inductor in terms of inductance and quality factor. And here we can see the difference in the behavior of the inductor. These are all electromagnetic simulations, so are physical simulation. From this physical simulation were then extracted a differential lumped equivalent model. Here we have the schematics of the model with the values of the inductor, resistor, and capacitor extracted from simulations. And this model then was used to resimulate the schematics of the designed VCO. And here in blue and red, I have pointed out an estimation of the parasitics that were believed responsible for the differences. So we can see parasitics on the bias line, we can see parasitic on the inductors, and the capacitor parasitics on the two oscillating points of the VCO. On the basis of this simulation and these considerations, a second design was carried out, and NIS communicated me just a few days ago that the new chip was delivered, and we expect to receive the chip here in Modena by the end of the next week in order to proceed with the test of the second prototype. These are the publications obtained by Paolo during his year. That's all. Thank you very much.